Please note that this content is targeted for solutions architects and SysOps administrators. If you're a developer, you may want to skip over this one.
And welcome back to Backspace Academy. In this lecture, I'm going to talk about application load balancers, which are a new type of load balancer that have been introduced by AWS, and it provides us a number of advantages. So we'll talk about the different options that are now available for us with load balancing, and then we'll talk about how an application load balancer can provide us with some significant benefits when we're running multiple applications. We'll talk about path-based routing and how that can reduce the number of load balancers that we need within our architecture. I'll also talk about the different options that we can route our requests to. We can route to IP addresses, we can route to microservices, we can route to different containers that are on a single instance. We have multiple targets, and we'll talk about what that means and the routing rules that we can set up that define how our requests are routed back to our back end. The load balancer options that are available to us include the original classic load balancer. Now that has always operated at both layer 4 and layer 7, but it's only provided really limited functionality at layer 7. So at layer 4, it's been offering us a standard TCP support, but also at layer 7, it's giving us HTTP and HTTPS support as well. But it doesn't support WebSockets, and so that is obviously a limitation at that layer 7 functionality. It supports VPC and EC2 classic instances. And the next option there we have is the network load balancer, which is another new load balancer option for us. And that operates specifically at the lower connection level or layer 4 of the OSI model. And so that supports TCP, and it's just grabbing packets and forwarding them straight onto our back end. It's very low level, but it also supports WebSockets. Now, WebSockets, they are in fact a layer 7 functionality, but it does also support WebSockets. But it doesn't support HTTP either. So we also have it supporting VPC only. It doesn't support the older EC2 classic instances. And there is another feature there that both the network and application load balancers have, and that is that it has load balancer deletion protection in case you accidentally delete that load balancer. So the one that we're going to be looking at in this lecture is the application load balancer, and that operates at the individual request level at layer 7 of the OSI model. And it's working very closely with our application. It's doing more than just grabbing packets and forwarding it on. It's putting those packets in a format back that our application can receive them. So it's going to be supporting HTTP, HTTPS, and also the new HTTP2, which is going to provide very good page load speeds. And it's also supporting WebSockets, which the classic load balancer doesn't support. It only supports VPC instances. It doesn't support EC2 classic instances. And again, it provides load balancer deletion protection. If we're looking to run multiple applications, if we're doing it with a classic elastic load balancer, what we would normally do is we would have our domain name service, our Route 53, and we would separate that into two separate domains. So over on the left-hand side here, you can see we've got our images domain, and over here we've got our app domain. So if we have our images domain, that will be serving our images, and our user interface functionality and all that will be served through our app. So if any requests come in for images, they're obviously going to come in through this classic load balancer here and then distributed onto one of the available instances, and likewise for any requests for the application. So that works, but the problem is that we are duplicating what we're doing here. So we basically have one elastic load balancer over here and a second elastic load balancer over there. Now with path-based routing, which is a feature of the application ELB, we can actually use one elastic load balancer, and the elastic load balancer will distinguish where that request has to go to depending on what the path is in that request. So if we have mydomain.com, they're all going to be coming in, and then if the path has images, the elastic load balancer will automatically know to send that through to this target group of instances over here. If it comes through with a path of app, then the application elastic load balancer will do the same for an available instance there as well. So what that means is that we're only using one application elastic load balancer as opposed to using multiple elastic load balancers for each one of those applications that we're running. So that's going to provide significant amount of a reduction in costs if you've got multiple applications that you're running. Another feature of elastic load balancers is that they can actually route to individual IP addresses. They don't actually have to have an instance. You can still register an instance with an elastic load balancer, but you can also register an IP address. So that can't be a public IP address. So you can't go and get something out in your on-premises database or whatever and route that. What you can do is that you can use one of the types of private IP addresses there that I've got listed, and you can use those to register with the load balancer. And so what will happen is that when we have our app or requests coming in for our app, they will come in through the application load balancer and go through to that IP address for that instance. Now, not only can we have multiple applications running through a single application load balancer, we can also have multiple applications running on the same instance, and we can register an instance and port combination for that application. So what that means is that if we have our app over here, so our request coming for our app, we can have that running on a microservice on an instance here, and then we can have our elastic load balancer set up so what it can do is it can receive requests for the app, and it can forward those straight through to that individual port or that application that is running on that port of that instance. And then we can do the same with another instance. So what that means is that if, for example, our images are not as busy as our app or vice versa, we are still distributing the load very evenly across these instances. So we're not going to have one side of this infrastructure that's going to be very busy and the other side not. So it's going to create some very good advantages for reliability and for efficiency as well. Another very good feature of the application load balancer is that it can actually run multiple containers on an instance and route or load balance across that as well. In a similar way that we would have multiple applications and we would register a port and an instance combination, we can do the same with a container that is running or multiple containers that are running on an individual instance. So again, we would have our application over here, and if my domain has app in its path, then those requests will be coming in through, and they will go to that ECS container that is running that application and the port combination for that. If you are using the ECS service to do that, it's quite good because the ECS service will manage all that for you. It will allocate the port and it will register that with the application load balancer for you. So with elastic load balancers, we still have listeners as we have before with a classic load balancer. So we would have a port 80 listener and a port 443 listener there if we're looking for HTTP and HTTPS traffic. And so that again defines a protocol and port for those incoming connections. But we also have what we call targets and target groups. So a target can be anything. It can be any combination of an instance. It could be a microservice, a combination of an instance and port. It could be a container, or it could be one of those private IP addresses that you can forward requests to. So what we would do, we would set up a target group with targets inside of it, and then we would register that with our application load balancer according to that path. So if we have our path here for images, that would be registered with that target group. So anything that's coming in for images will get forwarded onto that target group. If we have listeners and we have target groups that are going to receive those forwarded requests, we need to set up rules, and those rules will be defined at the listener. And so if we have, for example, there we have our port 80 listener, we can set up a rule that for any requests that come in on port 80 that have the path of images, so over here we have images, we can have that rule make a decision for the Elastic Load Balancer to send those requests or to forward those requests on to an available target within that target group. And likewise, we can have another rule set up to do the same for the app path as well. So that's about all I need to discuss for now about application load balancers. We're going to have a hands-on lesson now, and I'll see you in the next one.